a good way through it, at least to the point where we can probably answer some questions. So let's look at number 16. Describe the relationship between the number of factors in the function and its degree. So if we go back to the ones on the first page, the very first one I did, it's in fact, this is what we call factored form. Whenever it's got the parentheses and stuff, it's not multiplied out, hasn't been FOILed out or multiplied out. That's called factored form. And there's two sets of parentheses, meaning there's two factors. And what's the degree?
2.
2. And if you look at number 2, I got two sets of parentheses, and then I have that x out there, which is also a factor, because you would multiply it through. So it has 3 factors, and what's the degree?
3.
3. So what's the relationship between the degree and the number of factors?
Number of factors equals degree.
Number of factors equals degree. What is the general relationship between the factor of a function and the x-intercept related to the factor? So again, we can go back and we can look at the very first one I did up here. I have this factor, x plus 3, and it gave me this x-intercept, negative 3. And then I had this factor, x minus 3, and it gave me this x-intercept, positive 3. So what's the general relationship? Yeah, the sign switches. Now, you're exactly right. So let me show you why. Because if I have x minus 3, that's my factor, and I have x plus 3, those are factors. If I were to solve those, like to figure out what x is, I would set them equal to 0 and add 3 to both sides, and that gives me x equals 3, and this would give me x equals negative 3. So the general relationship between the factor of a function and the x-intercept, the factor is solved to get the x-intercept. And most of the time, like you just said, it's going to be a switched sign. That's not necessarily always exactly true in case there's something in front of the x, but a lot of times that will be what it is. All right, graphically, what is the difference between an x-intercept caused by a single factor, like x minus 3, and an x-intercept caused by a factor that is squared, like x minus 3 squared? So let's look up here at number 10. This is a good one to look at for this. I have one that's squared right here, and then I have these two that are not squared. So the one that's squared, that's at negative 2. Graphically, what happens at negative 2 versus what happens at 1 and 4?
There's a dip at the 2 and there's a
Yeah, exactly. That's exactly right. So she said there's a dip. We call them bounces because it's like the x-axis is a trampoline. And when it hits at that spot, it bounces back. So you can look at the same thing here, right? This one at x plus 2, that would be at negative 2 on the graph. It bounces at negative 2. The others just pass straight through. Does that make sense? So if that factor is squared, there's a bounce. So squared factors bounce, single factors just pass through. two of the preceding functions have graphs that point down on the right, or approach negative infinity as x increases. So as x goes to infinity, there's only two of them that approach negative infinity. Which two are they, and why? Number 3 and number 12. Why?
They have a negative x value in front of the parentheses.
Perfect. They have a negative x value. So if you look at number 3, it has this negative 2x. And if you look at 12, it has the negative 1.5x in front. So they do have a negative value in the front. All right, number 20. The number of x-intercepts on a polynomial function is the same as the function's degree. True or false?
False.
False. Now, it's almost true, isn't it? Like you think it's true, but where is it not true? What numbers of graphs is that not true?
14, 13, 14.
13 and 14, that's not true, because if you look at them, this one, obviously it has one bin, which means it has a degree of 2. I can look at the equation and tell you it has a degree of 2. But it has no x-intercepts. And this one is cubic. It's got one up, one down. It has two bins, this bin and this bin, which means it's cubic, so it's to the 3rd degree. But it only has one x-intercept. So that's false. Sometimes the graphs don't touch the x-axis. And we'll get into why and what that means a little bit later on. Okay, so now that we've done all of that investigating and we figured some stuff out, if they give you a graph in function form, like A, or they give you a function in function form, so it's already been factored for me, can you tell me what the x-intercepts are without looking at the graph?
-8, 0, 6, 0, 12, 0.
Perfect. Those are your 3 x-intercepts. So you don't really need the graph anymore, right? So my x-intercepts are -8, 0, 6, 0, and 12, 0. Without multiplying it out and without looking at the graph, can you tell me what degree this is? What? Yeah, it's to the 3rd degree. There are 3 x's. 1, 2, 3, which means it's to the 3rd degree. So it's a cubic function of some kind. Without looking at the graph and without multiplying it out, can you tell me what would happen as x goes to infinity? So on the right side of the graph, what's happening?
As x approaches infinity, y approaches positive infinity.
Perfect.
Sorry.
Because there's nothing in front to show that it's going down. There's no negative function. There's no negative factors here. So that means if it's a 3rd degree polynomial, it's rising to the right. All right, so looking at B.
Oh, that was for A. Sorry.
Yeah, that was A. So for B, we're not going to look at it or anything. I'm not going to plug it into the graph. Can you tell me what your x-intercepts might be?
-1, positive 37, positive 20, or not 37, 3.7, positive 22.8.
Good. So this one would give you -1. Can you tell me what would happen on the graph at that -1?
It would just.
Yeah, it would bounce because it's squared. So it's going to bounce at -1. So I know that I have one at -1, 0. I have one at 3.70. I have one at 22.80. And there's one more at 0, 0. This is the one, whenever you have an x by itself in the front, that is also an x-intercept. That one gets left out a lot, so try not to forget that. So with that said, what is the degree of this function? How many x's do you have? 4. It's to the 4th degree. Because this one right here is twice, right? It's because it's squared. So that's 1, 2, actually it's 5th degree, sorry. You have 1, 2, 3, 4, 5. Because this one is squared. So you have 5 x's here. So it's to the 5th degree, which means what about the arrowheads?
They'll go in the opposite direction.
Yeah, you've got one up, one down. Which one's up and which one's down?
But one of them, like, when it's positive, or x approaches positive infinity, y approaches positive infinity.
Exactly. So this one is rising to the right also because it doesn't have anything in front that's making it negative. Okay, so everybody good? So now, without using your calculator, we're going to use the information they've given us and we're going to see if we can graph these. So these will tell me my x-intercepts. So I'm going to have a x-intercept at -2. So I'm going to put a dot at -2. I'm going to have one at 1. And I'm going to have one at 4. All right, so this is 3rd degree, which means I should have one arrow up and one arrow down. And the one on the right-hand side should be going up because it's positive, right? So it's rising to the right, which means it'll look something like this. You all good? All right. So take a second look at B, see if you can sketch B on your own.
You want us to do C as well, or just?
Yeah, if you've done B, then you go ahead and do C. All right, on B, I should be passing through 0, 0 because of this x in the front, -3, and +4. And at +4, it should bounce. This is 1, 2, 3, 4. So my degree is 4, which means both of my arrowheads should be doing the same thing. And because it's positive, they're both going up. So that means it starts up, goes through here, here, bounces here, and goes up. Should look something like that. Anytime you encounter a quartic, one that's to the 4th degree, it's either going to look like a whacked out W or a whacked out M. It depends on whether or not it's positive or negative. If it's positive, it'll be a W. If it's negative, it'll be an M. All right? This one, I do have a negative in front. That means that the right-hand side should be falling. I should have one at an x-intercept at -4, -2, and +1. It's cubic, which means I've got one arrow up and one down. And this one on this side should be down because it's negative, so it's falling. So something like that. Notice on the y-axis they didn't put any hash marks. That's because it really doesn't care. They really don't care how big your bins are. This is just a sketch to make sure you understand that what the x-intercepts are, and that you can figure out the arrowheads and degree and all that jazz. Everybody okay? Makes sense?
This makes sense.
All right, so on this one, looking at it, what degree is it? 4. It's quartic to the 4th degree. I've got 3 bends. I also told you a second ago they look like W's. You should be able to write in factored form. So my intercepts, this is -3, 0, 2, and 4. So if I write them as factors, that's going to be x plus 3. The 0 will be at x in front. It'll be x minus 2 and x minus 4. Any questions? Last one, it is also to the 4th degree, it's an m. This one right here, so I've got one at -3, 2, and 4, but my 2 bounces. It's also negative, so I know this is going to be x plus 3, x minus 2 squared, because that's where the bounce happens, and it's -4, and then I have to make sure I put a negative in front to show that it's going down on both ends.
So x minus 4 or x minus 5?
Is it 5?
It is fine.
Sorry. Sometimes I can't count.
It's tricky when the
Counting
graph's
is
covered up.
tough for me. Okay, is everybody good? Awesome. Okay, put it up, keep it